Hi, I'm Nellie Fisher,
And I'm Bailey Fisher.
and we're working on creating a wearable device to help Parkinson's patients maintain an upright seated position. So here's just an overview of our poster before we get into everything.
So, Parkinson's disease affects 10 million people worldwide. There's currently no cure for Parkinson's disease, and there are many side effects that affect people with Parkinson's, such as tremors, stiffness, and inability to sit in an upright seated position. We wanted to focus on this side effect specifically, the upright seated position, because our grandmother suffered from Parkinson's disease, and we noticed that this was her biggest issue because she was not able to sit upright at a dinner table, which affected her ability to communicate with others and her inability to eat a proper diet.
So some studies that we took a look at, the first study is the Hellite Hip Safe, and essentially what this device was, it could be worn around the waist of a wearer, and as a person was walking around, this device could sense as they were falling over from a standing position, and thus inflate an airbag to be able to cushion the person's hips. The second device is very similar, which is the Walk airbag, essentially for the same purpose of promoting hip safety, but what this device focused on, it more focused on the smart technology of the device, so actually being able to predict a fall and learning from these falls that as they occurred. So the similarities is that both devices could be worn at all times, and they're both promote comfort and safety, but the difference is that the Walk airbag used the smart technology to predict falls and output data on the falls, thus making it a little more internet-oriented, which was something that we found very interesting.
So currently there's no device to help people with Parkinson's maintain an upright seated position. So our goal is to create this device that people need. So this is a large task to take on, so we want to break this up into a couple different parts. So for this, we are going to determine the acceleration threshold using an IMU sensor and an Arduino board to detect when a person is falling over in a chair.
So the overview of our suit, we actually have our prototype right here, but essentially on this left side, as you can see, first thing that we have is the sensor. So we chose to use an IMU sensor because it can measure orientation, velocity, etc. Then also what we used when we did the actual testing, we had a belt in this region, which was to ensure that the IMU sensor remained tightly secured up on the person's chest area. And then lastly, we have the Arduino board, which we placed in this pocket right here. And what this helped us, we chose an Arduino Uno, and this helped us to transfer the data from the IMU sensor to our computers.
So there are two components that aren't added in that vest, and that's the inflatable airbag and the air compressor. So the inflatable airbag was a SolidWorks generated model, and that airbag and that inflatable bag is where the air will eventually inflate to, which will bring the person back to an upright seated position. It'll also mold to the person's body so it's comfortable. We also have an air compressor that's going to be lightweight and refillable, so it'll be attached to the airbag and push a person back up to a seated position. So, to complete this study, we picked healthy participants from our community, and we demonstrated what it looks like for a person to fall to their left and a person to fall to their right. So then each participant sat in a chair and fell 5 times to their left and 5 times to their right. Our computer was getting the information from the Arduino board, and we were able to create a threshold and find when people were falling.
So as you can see from these graphs, first we have the left side averages, and then we have also the right side averages. As you can see on both of these graphs, on the line there is that bottommost point, which is in those circles, as you can see. And what these circles were, these were the first jerk. So that was the data point that we wanted to obtain, because that was when the person actually began their fall, which is what we want to use to be able to stop that person. So we want to detect that the fall is occurring there, and then be able to inflate to ensure that the person is not actually going further than that and actually falling over in their chair. As you can see, the left side is a little bit more unaligned. We believe that is because all participants were right-hand dominant, thus the left side was harder for them to fall over on. We also have the average not a fall graph, and what that was it was just when the person was sitting upright, and we can see that it's nearly a perfectly straight line, but there's some small deviations potentially due to accidental movements such as breathing. From this, we were able to actually create our threshold. So we took the largest number and the smallest number at the smallest speed at which the people were falling over, and thus we capped that as our threshold. So as you can see here, we have the left averages as well as the right averages. So from this, we conducted some significance testing, and we found that between the not a fall and the right fall, there was significance, as well as significance between the not a fall and the left fall. As well, we also found that there was not significance between the left and the right fall. What this showed us is that as a person is we noticed that the significance between the not a fall and the falls show that the device can differentiate between the person falling and not falling, and also that there isn't that much of a difference between the thresholds that go to the left and the right.
So the threshold can be used to program an eventual suit. We also did use healthy participants, so there was an 80% accuracy rate for people with Parkinson's. Our next steps is we would like to create a program used to detect when the person is falling over. So down below you see a code flowchart that we created, and that's basically an outline of what we want to create in the future. We also want to program the Arduino board to communicate with the air compressor to inflate.
So overall, to conclude, our device does satisfy our goals because we were able to find a threshold at which people accelerate as they fall over in their chair. Overall, this will allow us to promote life safety and promote normal life functions. And as we can see, there is a real need for a device like this to be created because falling over in a chair can be a really big threat to one's life. Thank you so much.
Thank you.